This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. Alright, in this video, I'm going to help show you how to find the 5 key x-coordinates for graphing the cosine or the sine function. So I have here the charts for y equals sine of x and y equals cosine of x, and you should be familiar with these. For one thing, you note that the period for the basic sine or cosine function is 2 pi. So notice for the x-coordinates, if it starts at 0 and the last key coordinate is 2 pi, that should be a total of 2 pi units. So the difference between 2 pi and 0, for instance, is 2 pi units. Now to get each x-coordinate, whatever the first x-coordinate is, we're going to go a fourth of the way from our first key coordinate to the last one. So if we have 0 and we want to end up at 2 pi, we remember we need to find these other ordered pairs in between it. Right? So one way of doing that is you're going to just add a fourth of the period. So you're going to add a fourth of 2 pi to get this new x-coordinate. Okay, so how about we draw that down here. Note one-fourth of the period is 2 pi. I'm sorry, 1/4 of 2 pi is pi over 2. So 1/4 of the period tells us the space between the first x-coordinate and the second x-coordinate of our key points. So we have 0, we're just going to add pi over 2 to 0, and that is why the second x-coordinate is pi over 2. Right? So in other words, I just added pi over 2, right, to 0. That's how I got it. Now how would I get the next one? I'm at pi over 2. I add pi over 2 again. I add 1/4 the period. All right, you could write that as 2 pi over 2 or pi. Okay. Now how would I get the next one? I'm going to keep it as 2 pi over 2 here. And I add pi over 2. I again add 1/4 of the period, and that's my 3 pi over 2. And if I do it one more time, if I take 3 pi over 2 and add a fourth of the period, I get 4 pi over 2, which is 2 pi. So that is how we get the x-coordinates. If we know where we're starting, in the case of y equals sine of x and the y equals cosine of x, we're starting at 0. We start with our first x-coordinate. We figure out the period, take 1/4 of the period, which is pi over 2, and add that to the first coordinate. So we start at 0. For both sine of x and cosine of x, start at 0 for your first x-coordinate, add pi over 2, add pi over 2 again, add pi 2 over 2 again, and add pi over 2 again. Now, you can write these with the common denominators, and actually I suggest that in most cases. So if we add pi over 2 to 0, we get pi over 2. If we add pi over 2 again, we have 2 pi over 2. Add pi over 2 again, we have 3 pi over 2, and then we've got 4 pi over 2. Okay, so it's up to you whether you want to write it with a common denominator or not. We'll find out that in most cases, if there's a phase shift especially, you're better off writing everything with a common denominator. All right, so let's try this one. Figure out the 5 key x-coordinates for y equals the cosine of 3x over 4. So there is no phase shift. Remember the phase shift, there has to be like plus something or minus something inside the parentheses. So we would just say the phase shift is 0, or you would say there's no phase shift. But what about the period? Okay, so let's do the period. The period is 2 pi divided by b. So in this case, b is 3/4. Okay. Note b is 3/4. So I'm going to do 2 pi divided by 3/4, which is 2 pi times 4/3, and we've got 8 pi over 3. So that is the period. So now we need to figure out what's 1/4 of the period. Well, it's 1/4 of 8 pi over 3. And let's see. Let's cancel. The 4 goes into the 8 twice. And so it's 2 pi over 3. That makes sense. 1/4 of 8 pi over 3 would be 2 pi over 3. Hopefully that makes sense to you. Now, if you don't have a phase shift, then our first x-coordinate is at 0. So if your first one is at 0, okay, that is your second. This 2 pi over 3 is your second x-coordinate because you'll be adding it to 0. So let's write down what we know. Let's just write the first x-coordinate, the second x-coordinate, etc. All right? So what would the first one be? Since there was no phase shift or 0 phase shift, it will be 0. The second x-coordinate will be just simply 1/4 of the period because you're adding it to 0. So I'm going to write down how to get it. It's really you're taking the previous x-coordinate and adding 1/4 of the period, which is 2 pi over 3. Third x-coordinate, what would you do? You would take the 2 pi over 3, and again, you would add 1/4 of the period. That gives me 4 pi over 3. Fourth x-coordinate, we would take what I have so far, 4 pi over 3, and again, keep adding 1/4 of the period. So that gives us 6 pi over 3. And then the fifth x-coordinate, we would take that 6 pi over 3. Let's see. And again, I keep adding 2 pi over 3. You keep adding 1/4 of the period. This gives me 8 pi over 3. Now, we know that the period was 8 pi over 3, right? Oops, sorry. That was the period. So I started at 0, and my last x-coordinate is at 8 pi over 3. So these will be our 5 x-coordinates. So let's put those in a chart. And the last thing I would say is before you put them in a chart, make them all with the same denominator. Of course, it's okay to just write 0. So if some of these x-coordinates had a 6 in the denominator, then I would just put everything in terms of 6. What's nice is here they all happen to have a common denominator. So let's make a chart now. All right, so remember, we're trying to get a chart for y equals the cosine of 3x over 4. And these are now how we get the 5 key coordinates. So for the cosine, 3x over 4, how would we get what those are the y coordinates we want? So since it's just simply the cosine of something, you could think of this whole thing as the y values in the basic chart for cosine x. So remember in the basic chart, it starts at 1 for the cosine, right? So we start at 0, remember it's the usual suspects here. Whoops, sorry. Technical difficulties. Okay, here we go. Pi, 3 pi over 2 and 2 pi. Remember how it goes? 1, 0, -1, 0, and back up to 1. These are the y values for the cosine of 3x over 4. So we get to just put those in. 1, 0, -1, 0, 1. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.